It's Nada Khatir again with you from Qarar Data Science. We've been talking about the different factors affecting modeling methodology. Previously, we covered how the modeling methodology is affected by who we are scoring and by what stage we're at in the credit life cycle. Today, let's discuss the third determining question: how much data do we have? When it comes down to data, the past can surely predict the future. The idea is that if you keep observing some outcome following some particular circumstances, then you can predict the outcome in the future if the same pattern is observed again. To build a scorecard that outputs the risk level of an individual based on their attributes, we need to observe similar individuals in the past to understand how this group would behave. For example, we might find that people who have missed more than 2 payments in the past are generally more likely to miss more payments in the future. So we assign that group fewer score points going forward. Ideally, we would like to have sufficient historical data describing a representative population as of a certain point, and also subsequent data on how they performed over the following months. This allows us to draw the connection between someone's current attributes and their likelihood to become delinquent in the future. If we have sufficient data, it allows us to build an empirical or statistical model, basing most of our decisions on the data. These decisions include how to define the target, who do we classify as delinquent, which characteristics are most important and how much influence will they have on the overall model, how many points do we assign individuals relative to each other to differentiate the risky from the safe ones. Having sufficient data makes our model more reliable and gives us more confidence in our results. But it's not a perfect world. Unfortunately, we don't always have all the data we need to make all our scoring decisions empirically. We may need to automate our onboarding decisions sooner than we can collect all the required data. In that case, we can put together an expert model where we draw on our experience from creating models for similar portfolios. However, when we resort to expert models, this should only be a temporary solution until sufficient data has been collected to build a more robust model. Sometimes we might have partial or incomplete data. That's where we can combine the two methodologies and go for a semi-expert model. Think of it like a gradient, or a balance between theory and observation, a trade-off between data and expertise. So the less data we have to build a model, the more we will rely on our expertise to compensate, but also the more closely we will need to monitor and tweak it. And that sums up how data availability affects modeling methodology. See you in the next video for a quick recap on credit scorecards.